Number 15 and 16 was all about identifying trig graphs. So both of them have them in cosine curves because you have that cosine curve looking shape that looks like a canyon. Again, a sine and a cosine curve are the same thing. There's just a 90-degree phase shift, a horizontal shift. So this is indeed a cosine curve. So the first thing I have to do is figure out what A is. Not amplitude, but A. So I see that, the picture, and I'm going to actually show you what the curve looks like in the calculator. The picture of the calculator, let's look at this from 0 to 2 pi, or 0 to 360. This is from 0 to 360. These are all 90 degrees apiece, because when I do a zoom 7, each x scale is 90. For the y, each y scale is 1. And I change my window to 0 to 360, and I just hit graph after that. So 0, 90, 180, 270, 360. You could see that it is the basic shape of the cosine curve. It's starting off like a canyon as opposed to looking like a big old anthill. So A has to be positive. If it were a reflection over the x-axis, then A would have been negative. If you count the distance from either the max to the min to the midline, it's going to be 1 unit. So A has to be 1 unit. If you want to use your calculation, you could do max minus min divided by 2, or 1 minus a negative 1 divided by 2 to get your 1 that way. It's just best to use the visual. Now, frequency by definition is the number of full cycles in a 2 pi interval. So you see how we see half the curve here? So the frequency is going to have to be 1/2. You could use the formula, but then you'd have to look at the full cycle of this curve, and I'd have to change my window. And a full cycle is going to have to go to 4 pi, or 720, to see the full cosine curve. So you see this is 0, 90, 180, 270, 360. Right here was the picture that they showed us. And here is going to be a full cycle, which is going to be 4 pi. So it would be 2 pi divided by 4 pi, or 1/2. It was much better to actually just look at the curve, locate where 2 pi was, and say that the frequency is 1/2 by the picture. Let's change that window back to 0 to 360. Just hit graph, because you don't want to do a zoom 7 and reset the parameters. So you can see that 1/2 is the frequency. So there's no shifting here. There's no vertical shifting, or else the curve would be up here or down here. So what's my curve? Y equals cosine 1/2. And now I put this into y equals. I put the curve in there. I do my zoom 7. And then I change my window after it's done graphing to 0 to 360. And I hit graph, and I can see that my picture looks exactly like the picture in the problem. Now, you could have done this, since it was a multiple choice, with back sub, put all 4 equations into y1, change your window after you zoom 7, and see which one matches the picture exactly. Now, with number 16, it was a little bit different, because with number 16, yes, it's a cosine curve, but you don't see 2 pi on the x-axis. So if I don't see 2 pi on the x-axis, I'm going to be forced to use my formulas. So the first thing we want to do, and if I can find the problem, because I'm looking all over the place here we go, is to find A. Now, A is once again going to be positive because it has that basic cosine shape, the canyon as opposed to an anthill. I'm going to use our formula to find it. It's going to be max, so A is positive, max minus min divided by 2. The maximum point was 5, and the minimum point, going up and down, is negative 1. So we're going to get 6 divided by 2, which makes A equal to 3. So we have our A. Now we have to find our B, our frequency. To find our frequency, it's 2 pi divided by the period. The period of the curve, if we look at the curve, I'm just going to bring up my computer screen a second. Sorry about that flash there. If we look at the actual curve here, do you see how this is one cycle of the cosine curve right here? Right? Hill and a valley. So we can see that the cycle ends at 4. There is no 2 pi here. So I have to use 2 pi divided by the period to get my frequency. If you said the frequency was 2, you'd be incorrect, because I don't see a 2 pi here. So you have to do 2 pi divided by the period of 4. So when I go back here, I do 2 pi divided by 4, And I get my frequency is pi over 2. There was no vertical shifting here, was there? Yes, there was. So, to get the vertical shift, which we did not do here, silly, the vertical shift is going to be max plus min divided by 2. So it's going to be 5 plus a negative 1 divided by 2, which is 4 over 2, or just 2. So the vertical shift, plus 2, had to go on the end here. So this is my graph, y equals 3 cosine pi over 2x plus 2. Now if you wanted to see a picture of this graph, you'd have to change your mode, because you could see that radians are involved here. And do you want to change your mode? You may. If you don't want to change your mode, you can change this to 90 degrees. 3 cosine 90x plus 2, and leave your mode in degrees. Or change your mode to radians, and then you do your zoom 7 to reset the calculator. Just be careful that if you do change your mode to radians, that you change it back immediately after you do the problem. I just put a definition of period here, that it's the time it takes to complete one full cycle. Okay? Hope that helped.